In this lesson, we'll discuss something we haven't touched on yet, linking files. Instead of making copies of files all over your system, it's sometimes desirable just to have links to one file. This is done with soft links or sim links, or with hard links. A link is similar in concept to a shortcut in Windows. Links are pointers to the actual file. There are two types: soft links, often referred to as symbolic links or sim links, and hard links. We'll discuss both in this lesson. Before discussing that, though, we'll take a look at inode numbers. You'll understand why shortly. Along with a name, every file is assigned an index or inode number. The inode number is how the system actually tracks the file. If we type ls minus li, I is to show the inode number, we'll see a leading number before the rest of the information on the file. That number is the inode number or index number. Every file on the system has its own unique inode number. The number of inodes on a system is limited, but it's very large depending on the file system in use. If we type df minus I, we can see the status of our inode usage on the system. We can see here the only file that's using an appreciable number of inodes is this dev mapper Ubuntu server vgroot, which is part of the Logical Volume Manager, or LVM, for this system. But it still has plenty of space. It's used only 24% of the available inodes. Most directories have only used less than 1%. You could get more information about a particular mount point with the tune to fs command. If we want to have a closer look at the dev sda1 mount, we would type sudo tune to fs -l /dev/sda1, and then we would grep for inode, because that'll give us a lot of additional information. So it tells us file system features, inode count, how many are free, inodes per group, blocks per group, first inode, and inode size. Now let's see how inodes relate to links. We have two files here, locs or locs.txt and locs2.txt. To create a hard link, we would type ln file name link name. Now if we do ls minus li again, we can see that locs and the hard link have the same inode number. It's essentially two names pointing to the same underlying file. Creating a soft link is very similar, but we add the -s option, so it would be ln -s file name and link name. Now if we do ls minus li, we can see there's a new soft link here. You can see it's light blue, that means it's working, it's not broken. And you can see an arrow pointing to the file it's linked to, the file name it's linked to, and you can see it has a completely new inode number. So a soft link essentially links to the name of the file, not the inode number. So how do these behave? Changing the name of a file with a hard link will not break the link, as it's pointing to the inode number, not the file name. We move locks to locks2. We can see both files are there. Both are still referring to the same inode number. And if we cat locks new, if we cat locks new.txt, it works. If we cat hard link to locks2, that also works. However, the same is not the case for soft links. If we cat the file now, it works. If we change the file name, we can see the link now shows as red, meaning it's broken, because locks2 is no longer there. If we try and cat that file, it doesn't work. The link is broken. Similarly, if you delete a file that has a hard link, the hard link still works. And the contents are still there. If you delete a file that has a soft link, it also won't work. How are these used in practical terms? If you have a web server, chances are the files that tell the server what pages are active will be symlinks to another file. Also, system files often use symlinks. That way you can change just an original file and all the links pointing to it are also seeing the new information. I don't have a web server on here, but you can see that rc0.d also uses links. All of these are links to files in initd. So that's it for links. Hard links and soft links. On to the next lesson. One thing you'll have to do quite often on your server is find files or directories. There are two primary commands you'll use to do this, find and locate, and we'll cover both of those in this lesson. Find is a very powerful tool for finding files based on many properties of the file. If we just scroll through here quickly, you can see our pages and pages of options. We'll look at some of the most common options and a few uncommon but very useful ones as well. For the most common usage, you just type find, path to search, and then options. To search by name, you just type -name. So to find all files from the root with the name myfile.txt, you get a lot of errors if you don't run as root. So you can either run this with sudo, or as you remember from a previous lesson, you could pipe errors to dev null. Dev null quietly drops anything sent to it. Another term for it is a bit bucket. So sending the errors out to dev null, we get two files. You can also use wildcards when searching for a file. So if we search for my file asterisk, you'll want to put this in double quotes, which is not a bad practice, by the way. You'll find a few more files. Instead of just .text, we've got a .doc and a .log. Let's see what happens if we don't put the double quotes. And it doesn't work as expected. It's because of the wildcard character. What we have to do if we don't put quotes around it is escape that wildcard character with a /. Using double quotes can keep things cleaner. Also, bear in mind you're not going to be able to see into certain directories if you run it as your own user instead of with sudo. All of the errors we avoided with the piping things out to dev null, they're all errors on places that we couldn't look at because of permissions. So for a thorough search, you'll probably want to run with sudo permissions. Let's say we want to find all files from a particular user. You could do find root from the root directory, or whatever directory you're interested in. And we'll use the user option, and we'll say L Skywalker. And again, we'll redirect errors to dev null. We can see if we would get the same results as root. And we do get the same results. One quick way to check that, though, at least as far as the number of lines, we could send it to wc-l. And we can do the same with the sudo command. Remember from previous lessons, wc is word count, and the -l option tells us how many lines match. So both of them come back with 8 lines. Well, there's the chance that one line is different in each, but it still comes out with 8. That chance is pretty slim. Probably they come out the same. You can also search by file type. The file types are F for files, L for links, S for sockets, and D for directories. So if we do find from root with the type D for directory, the name new dir, and we pipe the errors, and we redirect the errors to dev null, and it found one. We can also use wildcards. If we can't remember the exact file name, or we want several files with similar names, we'll use the asterisk character. That's above the 8 on a North American keyboard. We'll do find in the present directory with the name, and then we'll do double quote, asterisk, y_file, and then double quote. So it found myfile.doc, this is myfile.log, myfile.text, and myfile.log. It found all of those with this search pattern. If we change that a little, we put the M here, it only finds things with my file in it. So it didn't find this is my file.log. We can also ignore case. And the way that you do that, remember that Linux is case sensitive. So myfile.log and myfile with capital M are different. But the way we can do that is very easy in Linux. We can ignore case by typing an I in the name option. So you can see it included myfile.txt with a capital M and a capital F there. We can also find files or folders based on the permissions set on the file or folder. So if we want to find everything in the home directory that's a directory that has the permissions of 755, we can see everything from /home down has 755 permissions. There's also a not operator. The not operator finds everything that doesn't match a particular query. If we do a find on the present directory that's case insensitive on my file and everything that isn't a text file, we'll use the exclamation mark for not and name, and then anything with a .txt on the end. So it did find myfile.doc and myfile.log, but it filtered out the text files. So we just go back here, we can see that there were 2 text files that were overlooked because we asked it to. You can also perform operations on things that are found by the find command. If you remove a user with the del user command and you don't specify the remove all files option, some files may be left behind and they'll have no valid user assigned to them. These are called orphan files. And we can see we had a user named Jabba. It looks like that user was probably deleted, but there are files still there on the system. So we'll run sudo find from root any files that have no user assigned. We'll redirect errors to dev null. Then we'll pipe the remaining output to xargs and then to sudo rm. So it'll find any files with no user, remove errors, send the remaining ones to rm. And of course this won't work with a directory. That's okay, this is one directory. So we can just take a quick look at, we could just remove that directory manually. Or we could have run the rm with the -rf option, and that would have also gotten rid of directories. We'll just do this manually though. And then we'll try and find anything left with no user assigned. And we get nothing. Clean output. So we have no more orphaned files. The files without users, again, are called orphaned files. We've only scratched the surface of what you can do with the find command, so please experiment yourself, but do so carefully if you're doing operations on the files. Especially if you're running with sudo permissions, a mistake could heavily damage your system, so be careful. Another command you can use to find files is called locate. Locate seems kind of similar to find, but you can see it doesn't have nearly as many options. The syntax is really simple though. If we ls, so we tried locate on my underscore file. We know we have some files in my directory that start with my file or have my file in them. So why aren't they showing up? Locate works very quickly because it searches a database of file information. It doesn't actually search your file system. And the way you update that database, it runs at midnight every day. But we've made these files today, so they aren't in the database yet. The way you update it manually is to do sudo update db. Now if we try that command, it finds the files. If I'm searching for a file and I just want to do a really quick search, and I'm not that concerned with doing it on the whole system or doing any options with it, I'll often use locate after running the update db command. If I want to do anything more sophisticated, I'll use find. My suggestion is to spend a lot more time learning find and just kind of get a quick understanding of locate. And that's it for this lesson on finding files. Good job. To use SSH to connect to your server, you'll have to prepare it with 3 things. Make sure OpenSSH server is installed. Make sure you can connect to your server over the network. And make sure you have a firewall exception for SSH. We'll cover each of those in this lesson. The first step is to install OpenSSH server. If you selected that option when you were building your server, it should already be installed. But you can see if it's installed by typing man sshd config. If you get an error back, that means SSH server is not installed. And since it's not installed, we're going to update our server. And then we're going to install OpenSSH server. To update, we just type sudo apt update. Everything's up to date. Then we type sudo apt install open SSH server. Hit yes to continue. Now if we type man sshd config, we get a manual page entry. So it looks like it installed okay. Now we have to configure networking. So we'll shut down our server. And in VirtualBox, we can see it's powered off. So we right-click and go to Settings. Click on the Network tab. And under the drop-down, we'll click Bridged Adapter. I'm assuming for this course you're on a home network that's protected by some kind of wireless router or firewall, or you're on a corporate network. If your computer is directly connected to the internet, you'll want to make sure the root account is disabled, and you'll want to make sure that you have a secure password on your user account. So please do those things as soon as you boot up after we do this, before enabling SSH, which we'll cover later. So we select Bridged Adapter, click OK. Then we power on by double-clicking. And we log in. So typing IP ADDR and grepping for INET will tell us our IP address. Now we should be able to ping that from our computer. The IP address we want to ping is 192.168.254.105, so we'll try that. Ping is a network program designed to help us troubleshoot network issues. Our server is replying, so we're good. Hit Control-C to stop. So networking is all set up for us. If you're directly connected to the internet, you'll also want to make sure your server is up to date. We'll do apt update, sudo apt update. Then we'll do sudo apt upgrade -y. Then we'll do sudo apt full upgrade -y. Our server was already up to date, so it didn't do much, but hopefully if there was anything missing, your server is up to date now. Now we'll configure the UFW firewall. There's a full lesson on setting up the UFW firewall in the Securing Your Ubuntu Server section in the lesson entitled Enabling Your Firewall UFW. Here we'll do the bare minimum, prepping your server to accept connections over SSH on TCP port 22. To check the status of your firewall, just type sudo UFW status. If it says status inactive, that's okay at this point. First we'll allow SSH. And it says the rules were updated. Then we'll deny incoming and allow outgoing traffic. Type sudo UFW default deny incoming, and then sudo UFW default allow outgoing. Then we enable the firewall by typing sudo UFW enable. We check it by sudo UFW status. And if you want more information, you can type status verbose. It tells you the default statements when you use verbose. Now that we've installed OpenSSH server, configured networking, and enabled the firewall, we'll start the SSH service. To do that, you just type sudo service SSH start. To check it, we can type sudo service SSH status. You can see that it's loaded and running. Or we could check with netstat. Just type netstat. Just type netstat -tanup and grep for SSH. We'll have to do sudo. There we go. And you can see that port 22 is listening, which is the SSH. And that it's the SSHD service that's listening. Now your server's all ready to go. On to the next lesson for configuring remote access.